with another class. I'm Dr. B, your chemistry teacher, online. Today, you and I will be discussing hydrocarbons. And under hydrocarbons, we'll be looking at alkanes, alkenes, and alkynes. And importantly, we will be looking at the general overview of hydrocarbons. And in subsequent classes, we'll take alkanes, alkenes, and alkynes one after the other. And today, let us look at the overview of what hydrocarbons are all about. Now, do not forget that you have to share this class. You subscribe, Dr. B Science classes. You share, tell them to subscribe as well. So once these videos are up, it pops us immediately on their phones. Now, if you go to Facebook, you have the same Dr. B Science classes. Share, ask them to follow as well, so that you can enjoy what we are doing this other side. Now, there are comment sections. You can leave your questions there as well, or any comment at all of appreciation. You can also like at the same time. Alright, now today we are going to look at hydrocarbons. Now, do you know that hydrocarbons form the world's main and major energy source? Yes, the entire world main or major energy source rests on hydrocarbons. You can see how very important, how very relevant hydrocarbons are. Hydrocarbons are always known to belong, they are examples, let me put it that way, examples of group 14 hydrides. If you take a study through the group 14 hydrides, you'll see that much of the hydrides are basically hydrocarbons. Now, this is because hydrocarbons are usually formed from 3 different sources, and one of those sources is coal. Okay, one of those sources is coal. Okay, so you can see that when you talk about Enugu State, the coal city, okay, it is one of those areas we have dominance of or abundance of hydrocarbon in Nigeria. Okay, so coal is one of the sources of hydrocarbon. Again, petroleum is another source. Okay, petroleum is another source of hydrocarbon. Of course, we expect that because petroleum is part of the products you can obtain from crude oil. And every part of crude oil, every product obtained from crude oil is basically composed of hydrocarbon. Hydrocarbons are known to be composed of hydrogen and carbon. So compounds that are mainly hydrogen and carbon are described as hydrocarbon. And petroleum, which is obtained from crude oil, and every other product obtained from crude oil is hydrocarbon in nature. And then you can also get hydrocarbon from natural gas. Now, these are the 3 main sources of hydrocarbon: from coal, from petroleum, from natural gas. No wonder methane, CH4, is natural gas, and it is comprised of carbon and hydrogen only. You can also have, by way of addition, you can also have hydrocarbon derivatives. Hydrocarbon derivatives can also be synthesized to give you hydrocarbons at the end of the day. So the major sources of hydrocarbon are coal, petroleum, natural gas, and to some extent, hydrocarbon derivatives. Yes. Now, do you know that hydrocarbons can, they have quite some properties, and one of those properties is the issue of color. Hydrocarbons are seen to be colorless. Now, if you read further, you will know why hydrocarbons are seen to be colorless. Hydrocarbons also are known to be hydrophobic. That means that they are water-hating, because hydrophilicity means that that particular substance or that particular thing is water-loving. But hydrocarbons are hydrophobic in nature. Now, take a look at soap production. Do you know that when you produce soap and you decide to use that soap to wash your clothes, for example, talking about the cleansing action of soap, okay, you will notice that the soap has 2 ends, and one of the ends is the tail and the other one is the head. The one that is the head is water loving. The one that is the tail is water hating, is hydrophobic, and that is the hydrocarbon part of the soap. So you see that hydrocarbons are actually and naturally what? hydrophobic. They have smell though, very mild smell, very mild odor, and the odor tastes like the odor. I mean, the odor is perceived like it perceives something that looks like a lighter fluid. Okay, if you break a lighter or you choose to open a lighter, for example, the fluid, that is the way the hydrocarbons smell. All right. Now that is some properties of hydrocarbons, basically physical properties of hydrocarbon. Now, do you also know that hydrocarbons take different forms? Okay, hydrocarbons take different forms. Hydrocarbon can exist in the form of a gas. Okay, so we have gaseous hydrocarbons. Hydrocarbons can exist in the form of gas, and the very low carbon containing compounds, or let me say, take for example the alkanes. Okay, the smaller number alkanes that range from methane down to butane are always gases in nature, or rather gaseous in nature, and those are hydrocarbons. So hydrocarbons can take the form of a gas, and typical example is methane. Okay, so methane, propane, okay, butane, all these are hydrocarbon ranging from carbon atom 1 to carbon atom 4. Okay, and these are the lower carbon atom hydrocarbons. Now, they are always gaseous in nature. Hydrocarbon can also take the form of a liquid. And those particular hydrocarbons that have heavy carbon atom or higher number of carbon atoms, ranging from about 6 down to 10 or even more, will always exist in the form of a liquid. And a good example is benzene and hexane. Okay, so when you look at the liquid form of hydrocarbon, you'll see that benzene is 1, which is C6H6. You'll see that hexane is 1. And hexane is, of course, it is C6H14, and that is hexane. You can see that those particular alkanes, for example, that have a higher carbon atom are always exhibiting liquid form in terms of hydrocarbon. So hydrocarbon can exist as as gas, as liquid. And again, to some extent, hydrocarbon can also exist as solids. But this time, the solids are low melting point solids. Okay, so as low melting point solids, hydrocarbon can exist there as either naphthalene or paraffin wax. In fact, all the waxes are classified under the low melting point solid hydrocarbons. Paraffin wax is an example. Remember, paraffin wax is used in a lot of things, especially those who produce things like creams, emulsions made of paraffin wax, and these are actually hydrocarbons, but in the solid form, low melting points. And then you can also talk about naphthalene. Okay, so naphthalene is also another good example of what? Of hydrocarbon, which is a low melting point solid hydrocarbon. Okay, so all these are the various forms hydrocarbon can take. So you can take a gaseous form. An example we said is like methane, propane, butane, hydrocarbons of lower carbon atoms. It can take the form of liquid, for example, benzene or hexane or even heptane. And these are hydrocarbons, these are compounds with hydrocarbons of higher or larger carbon atoms. And it can take the form of solid, but a low melting point solid. You must take note of that. And we saw naphthalene or even paraffin wax as good example of hydrocarbons at this level. Do you know that hydrocarbons can also exist as polymers? Of course, hydrocarbons can also exist as polymers. So you can have hydrocarbons as polymers. Of course. So as polymers, hydrocarbon can actually exist as polystyrene, or can even exist as polyethylene. Polyethylene. So it can exist as polystyrene or polyethylene. Now, as polystyrenes are actually aromatic compounds. Now, aromatic hydrocarbons can exist in the form of polystyrenes or polyethylene. Alright, and these are polymers. So it means that hydrocarbon can not only exist as solid, liquid, or gas, they can also exist as a polymer. Now, as a polymer, polystyrene is there. Polystyrene is actually a monomer. It's a compound that is formed out of monomers of what? Of styrene. Of course, you know that styrene is C8H8. So its polymer is what its monomer rather repeatedly form a chain that leads to a compound you can describe as polystyrene. So polystyrene is what? Is a hydrocarbon. It is actually an aromatic hydrocarbon that its monomer are styrene, and the repeated chains will form a polymer which we call polystyrene. And usually polystyrenes are used in formation or production of plastics. Okay, so plastics like fuel plates that you use, like plastic takeaway plates that you have, they are all polystyrene, and usually they can also be used in smoke detectors in the house. Okay, they have those this way, but we have smoke detectors in the house that once a house is filled with fumes or smoke, it starts giving you an alarm. Okay, so smoke detectors, plastic plates and plastic spoons and all those stuff, they come from even cases of jewelries are all polystyrene. Now you also have polyethylene, which is used also for packaging, and they are formed from monomers of ethylene, C4H4, monomers of ethylene, C2H4 ethylene, monomers of ethylene. So monomers of ethylene, which are also they are also aromatic hydrocarbons. Those monomers will form repeated monomers and form a chain that will create a compound that you call polyethylene, which is used for packaging most importantly, but other uses are there as well. So you can see that hydrocarbons can exist in different forms. Can exist as solid, of course, as low melting point solid. We must be very specific about that. Low melting point solids, okay, where we see examples turning around paraffin wax, turning around naphthalene, or can even exist as liquid. Examples turning around benzene and hexene, as we have discussed earlier, or can even exist as gases, turning around methane, butane, and even propane. It can also exist as polymers, turning around polystyrene and polyethylene. Okay, now these are the different forms of hydrocarbon, but we also have the different classes of hydrocarbons, and that is what we must not throw away so easily. Okay, so hydrocarbon exists in different classes as well. We have seen the different forms. Now these are the different classes. Now hydrocarbon is divided into two major classes: aliphatic and aromatic hydrocarbons. Okay, aliphatic hydrocarbons are known to be basically compounds with localized orbitals. That means that their electrons are actually being made to be centered at a particular point of the orbit. Now, but these very aliphatic hydrocarbons are divided into acyclic and ancyclic hydrocarbons. Acyclic hydrocarbons and cyclic hydrocarbons. Now, acyclic hydrocarbons are simply hydrocarbons that are either straight chain or branch chain hydrocarbons. For example, if you look at the straight chain, if I write this for you, this is 1, 2, 3 carbon atom, and then you have methane, ethane, you have propane. So that means this is what propane, C3H8. Now 1, 2, 3, 4, 5, 6, 7, 8, C3H8. That that is propane. Now, this is a straight chain hydrocarbon, and it belongs to the acyclic hydrocarbon. Now, you also have the branch chain hydrocarbon. So, if I decide to write something like, if I choose to move this, and I put this, and I use this, and probably probably have this. Okay, so this is 1, 2, 3, 4, and this of course is butane. So this is if I'm counting from here, this is 1, this is 2, 3, and 4 carbon atoms. So this is actually 1, 2. So this is 2 methane, 2 what? 2 methane what? Or 2 methyl what? 2 methyl butane. 1, 2, 3, 4. So this is 1, 2. The methyl group is at what? The second carbon atom. So I can say this is 2 methyl what? 2 methyl butane. 2 methyl butane. Now, this is a branch chain hydrocarbon. So whether it is a branch chain hydrocarbon or it's a straight chain hydrocarbon, they are all classified as what? As acyclic hydrocarbons, and they belong to a parent name called aliphatic hydrocarbons with what? With localized orbitals. Now, we also have cyclic hydrocarbons that are also belonging to this aliphatic hydrocarbon. Of course, cyclic hydrocarbons are having a closed ring chain. They are in a ring form. Okay, but a chain in a ring form. This time around, they are not branch or straight chain hydrocarbons. So we can easily describe that. So if you look at an example of a cycloalkane, okay, for example, something like cyclohexane. Let's say cyclohexane, we expect it to have 6 carbon atoms, but this time in a cyclic form. So it has a closed ring chain. So in that case, we'll have cyclohexane. We'll have a cyclohexane as okay. This is a carbon atom. These are carbon atoms. 1, 2, 3, 4, 5, 6. And this, of course, will be giving us hydrogen at the end of the day. Now, this is a typical cyclic hydrocarbon that has a closed ring chain. And this is a cycloalkane, and its name is cyclohexane. So you also have a cyclohexane, you have a cyclopentane, you have a cyclobutane, and all these cyclo are all what? Are all closed ring chain compounds belonging to cyclic hydrocarbon and aliphatic hydrocarbon. Alright, now that is interesting. Also know that another class of hydrocarbon apart from aliphatic is the aromatic hydrocarbon. Aromatic hydrocarbons have non-localized orbitals. And a typical example of these aromatic hydrocarbons is benzene. Now, if you write benzene in this format, okay, the difference between non-localized orbitals and the closed ring chain, okay, that are localized orbitals, is in the presence of these 3 bonds that are inside, forming double bonds, 1, 2, 3, let's say triple bonds in this compound. So this is benzene with C6H6, that is benzene. And remember that benzene is a typical example of a liquid hydrocarbon. We had mentioned that before. So benzene is a typical example of an aromatic hydrocarbon, and aromatic hydrocarbon is an example of a cyclic hydrocarbon, except that this time around the cyclic hydrocarbon is with what? With 3 bonds inside them, forming what? Forming a localized orbital at the end of the day. Now, do you know that apart from hydrocarbon being classified as aliphatic and aromatic hydrocarbons, hydrocarbon can also be classified as saturated and unsaturated hydrocarbons. Saturated hydrocarbons are actually hydrocarbons that we could classify under the straight chain and branch chain. That means saturated hydrocarbons can actually be acyclic. Yes. It means that saturated hydrocarbons can actually be acyclic. They are hydrocarbons that have just what? Carbon-carbon single bonds. And when we drew diagrams that we have drawn earlier, this kind of structure is describing where you have only single bonds, is describing a saturated hydrocarbon. And of course, this is what we have used earlier to discuss what straight and branch-end hydrocarbons, which are acyclic. So that it means that as much as aromatic hydrocarbons are cyclic hydrocarbons, even saturated hydrocarbons are what? Are acyclic hydrocarbons. And mostly straight and branching hydrocarbons. Now, the unsaturated hydrocarbons are described as hydrocarbons that have carbon-carbon what? Multiple bonds. So, example of these saturated hydrocarbons can be seen in alkanes. And since we said unsaturated carbons has multiple bonds, so it means that compounds that has carbon-carbon double bonds and carbon-carbon triple bonds are compounds belonging to unsaturated hydrocarbons. And these compounds can actually be seen in alkenes and in alkynes. I hope you enjoyed this class today. This is the much I can go with you on the overview of hydrocarbons. The next time you are going to see my class popping up, we'll be discussing saturated hydrocarbons, which are the alkanes. And then subsequently we'll talk about the unsaturated, which are the alkenes and the alkynes. Do well to share, do well to subscribe, do well to also like and to comment. Until next time.